Hello, good day to everyone who's watching this video. So in this video we will see the uh, uh, two-port network analysis of a transformer, of ideal transformer. See, by default you have to assume transformer as ideal. Okay, so this is just a discussion. Keep this in your mind. You don't need to mug up simple transformer thing. See, now in the two-port network we have this transformer. Okay, so in any two-port network it is a very standard thing that if this is a two-port network, it's a two-port network. Okay, and there are branches like this, so the current directions are always like entering from both the sides. Okay, and it's leaving like this. Okay, so that is the very standard basic model of the two-port network. Okay, you have to assume the currents by default in coming inside the network. Okay, so I hope you know this much. Now coming back to our discussion, we have this transformer. Okay, so I'm assuming the current direction I1 in this and I2 in this direction. Okay, and the turns ratio I am assuming as 1:n. Okay, you can assume it n:1 or anything, just focus on the discussion. So this will be plus minus V1 and this will be plus minus V2. Okay, so this is our 1:n ideal transformer. Now simple. Now just you have to remember one thing. See, since we have assumed the secondary branch, secondary side direction as inside the transformer, we all know that in practically this is not the case. The current comes out of the secondary of the transformer. Okay, so we have to assume the minus I2 while writing our standard equation for the transformer, that is V1 by V2 is equal to what? 1 by n is equal to minus I2 by I1. Why minus? Because we have assumed the direction in the coming inside the transformer. And why we have assumed so? Because in ideal, in the two-port network analysis, we usually take it's not usually, it's a standard that we have to take the current directions coming into the network. Okay, so using this relation you can easily see here we have V1, we have I1, I2, so we can easily write down the Z, what do you say, that the Z parameters. Okay, let us try finding out the Z parameters if possible. See, we know the equation V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Okay, now can you find out sign equation like this? V1 is equal to V2 by n. I could find out V1 is equal to, or I1 is equal to minus n I2, I could find out. Okay, so we cannot find out these Z parameters. Okay, so this ideal transformer does not have Z parameters, and we also cannot find out the Y parameters. You can also see this by writing the equation. See, what is this? I1 is equal to Y11 V1 plus Y12 V2. Okay, and I2 is equal to Y21 V1 plus Y22 V2. Okay, we cannot write this Y matrix also for this ideal transformer. Why? Because from these relations, what equation can we see? V1 is equal to V2 by n. Okay, and we could also see that I1 is equal to minus n I2. So, and we could write it down as V1 is equal to V2 by n, and V1 does not have any does not have any dependence on the current. Okay, so I could take here 0 I1. Okay, so from here I could get idea that I could easily write the G and H parameters for this ideal transformer. Okay, so let us write down those. Okay, I hope you get the idea. See, what is our G parameters? G parameters are I1 is equal to G11 V1 plus G12 I2. Okay, and we have V2 is equal to G21 V1 plus G22 I2. Okay, and we have our H parameters as just interchange. It will be V1 I2, and here it will be what, I1 V2. Just interchange the alphabets. So this will be H11 plus H12 H21 H22. Okay, see here we could see that here I has dependence on V1 and has dependence on I2 by using G parameters, and from our relations we could see that I has dependence on only I1. Okay, by using this relation. Okay, so using these relations I could easily find out. Now see, V1 is equal to 0 I1 plus 1 by n V2. Okay, so this is, we have the H parameter one equation, and now we have I2 is equal to what? From our previous, I2 is equal to minus I1 by n. So minus I1 by n plus 0 V2. Okay, so we have got our H parameters as 0, 1 by n, minus 1 by n and 0. Okay, similarly you could analyze for the G parameters. See, here we need relation between I1 and V1, or I1 or I2. So I could take I1 this side and I could easily write minus n I2. Okay, using those relations only, and V2 I can easily write out n V1 plus 0 I2. Okay, so that is also nice thing. So the G parameters are 0, minus n and 0. Okay, so you don't need to learn these parameters. You could, if you just remember that you have to assume the directions in this fashion, and when you assume, you have to assume this negative sign, then using this relation only you can easily see these things. Okay, now let us write ABCD parameters also. Okay, so we know that ABCD parameters are V1 is equal to AV1 minus BI2, and I1 is equal to CV2 minus DI2. Okay, so from the relation we could easily find out V1 is equal to 1 by n V2 minus 0 I2, and your I1 is equal to minus 0 V2 minus n I2. Okay, so you have got your ABCD parameters as 1 by n 0 0 minus n. Okay, so these are your ABCD parameters. So the overall concept of this is the ratio, that for a ideal transformer with the ratio 1 by n given to you, and you have assumed the directions in this fashion, you can easily find out the G, H and ABCD parameters for that thing. Okay, so that is all about this discussion. So the only takeaway is just you should remember how to write this equation and never forget to take the sign according to the current directions. Okay, so if the direction changes, your sign changes. That is very important. Okay, so I hope you get the idea and how you can generally analyze the ideal transformer as a two-port network. Okay, so thank you, and I hope you get this, and have a nice day. Okay, bye. And please like, share, subscribe Electrical Diaries. You can visit our website for doubts and anything. Okay, so thank you.